Hi, my name is Allie Champion. I live in Arlington, Virginia, and I'm currently in the Masters of Cybersecurity at NYU program. Today, we will discuss how to leverage AI-driven threat intelligence to predict and prevent financial fraud. So, the problem is that fraud attacks are one of the most prominent and damaging threats facing the financial sector today. Traditional fraud detection systems fail to adapt to the increasing sophistication of cybercriminals. To mitigate the impact of similar types of fraudulent attacks, we propose an AI-based threat intelligence platform. Our proposed solution uses machine learning and AI techniques to detect and prevent fraudulent activity real time. In this presentation, we will assess the performance of the solution by analyzing and comparing the fraud detection rate, false positive rate, false negative rate, average detection time, precision, recall, and F1 score to those of a standard machine model and a rule-based machine model to determine effectiveness. For a motivating example, we will explore the case of a financial institution experiencing a sudden increase in fraud attempts due to a data breach from a third-party vendor. Let's call the financial institution Acme Finance. In the first scenario, we will utilize traditional fraud detection systems. This traditional system will apply pattern recognition from past incidents and therefore only flag these suspicious transactions after the surge has occurred and the damage has been done. In the second scenario, we will utilize our predictive AI-based threat intelligence platform. We will analyze each customer's spending behavior real time, spot anomalies based on the established baseline, and put a halt to these transactions before they are fully completed. For example, a customer named Sally Mae doesn't typically travel, and if she has, it is within the United States. One of her recent transactions, dated 4/21/23 with a timestamp of 5:56 p.m., states that she spent $4.95 at Dollar General in Buffalo, New York. Her next transaction, on the same day with a timestamp of 8:57 p.m., states that she spent $920.44 in Beijing, China. It is implausible that this was a legitimate transaction, and an example of a very straightforward scenario, but this occurrence of fraud was immediately halted before it even reached the detection stage and was flagged for review. One of the most profound issues today that impacts the financial sector is fraud. And almost 75% of financial institutions have implemented or have a plan to implement AI-driven anti-fraud solutions within the next 2 years. The solutions that currently exist are reactive, analyzing historical fraud attempts rather than proactively predicting them. We propose utilizing an AI-based threat intelligence platform to analyze financial transaction patterns over time from multiple sources and build predictive models that are tailored to an individual or organization's financial activity. Specifically, the solution would combine both AI and machine learning. The types of machine learning include supervised learning, unsupervised learning, and deep learning architectures. It would also implement anomaly detection using AI. This system would detect fraud with higher accuracy, lower false positive rates, and a reduced detection times. Ultimately, AI would not only detect fraud after the fact, but could predict and stop fraudulent transactions ahead of their occurrence. Here, we studied 3 different papers and their research relating to machine learning and threat intelligence platforms. The first paper is called The Quest for the Appropriate Cyber Threat Intelligence Sharing Platform and studies the different open source threat intelligence platforms and compares them. This research paper notes the importance of utilizing cyber threat intelligence within organizations, mainly because they provide increased awareness, security posture, knowledge maturing, and defense agility. This research provides context for the proposed issue, but would be difficult for use in a financial institution. Open source threat intelligence platforms are not tailored to meet the stringent requirements of safeguarding consumer data and can even pose significant data privacy risks. Next, the article named Financial Fraud Detection Through the Application of Machine Learning Techniques, a Literature Review, emphasizes the need for exploration and application of unsupervised and deep learning models in financial detection methods in financial institutions. It highlights the need for more advanced machine learning algorithms mainly to reduce the false positive rate, a common issue arising in fraud detection. However, the article mainly focuses on one type of fraud, credit card fraud. We will focus on account takeover fraud, identity fraud, credit card fraud, loan fraud, and other types of fraud that are prominent in the financial industry. The same machine learning techniques will be utilized, such as unsupervised, supervised, and deep learning, to create more resilient threat detection systems. Lastly, a rule-based machine learning model for financial fraud detection proposes a rule-based model using metrics such as accuracy, precision, and the ROC curve to detect financial fraud. The model would classify financial transactions as fraudulent or otherwise based on rules. However, rule-based systems are known for their high false positive rate and can lack contextual awareness and be slow when responding to threats. The proposed method will improve upon these shortcomings. So, for implementation, multiple experiments were conducted for our threat intelligence platform using anonymized transaction data. This aims to simulate a financial institution under fraud attack, because some of the most common types of fraud in financial institutions are identity theft, loan fraud, and credit card fraud. The models were trained to detect these specific types. Each system was evaluated using the same dataset, which includes 2 million transaction records, a fraud rate of around 3.7%, and transactional metadata such as transaction ID, amount in US dollars, location, device type, historical pattern match, and true label. We will compare 3 different types of machine learning models. The standard machine learning model, which involves the use of supervised learning techniques, including k-nearest neighbors and logistic regression. The rule-based machine learning models, which involves the use of heuristic-based rules, for example, behavioral, time-based, and thresholding rules. And the proposed AI-based threat intelligence platform, which combines both AI and machine learning, using supervised learning, unsupervised learning, anomaly detection, transfer learning, and deep learning, i.e. deep neural networks, DNNs. This solution can continuously learn and adapt to emerging threats. And then we use the evaluation methods below to compare the 3 machine learning models. We use the fraud detection rate, FDR, which is the number of fraudulent transactions correctly identified, the false positive rate, which is the number of legitimate transactions incorrectly identified as fraud. The abbreviation is FPR for that. The false negative rate, FNR, which is the number of fraudulent transactions the model did not identify as fraud. The average detection time, ADT, which is the average time it takes for a system to identify a transaction as fraudulent or legitimate. Precision, which is the actual number of fraudulent transactions out of all of the transactions the system classified as fraudulent. Recall, which is the number of successfully classified fraudulent transactions. And lastly, the F1 score, which is the harmonic mean of precision and recall. Here's a sample dataset from the full dataset that we used. We will discuss the findings in the next few slides. So for context, we want the fraud detection rate to increase, the false positive rate to decrease, the false negative rate and average detection time to decrease, and precision, recall, and F1 score to increase. This would be the ideal scenario. As you can see here, the full dataset outperformed our sample dataset a bit. And we have achieved our goals of the proper metrics, either increasing or decreasing exactly how we would want them to. So as you can see here, we would definitely want to use our proposed AI-based threat intelligence platform because it had a higher success rate in every metric than both the standard machine learning model and the rule-based model. So for next steps, there are several areas within this study that could definitely benefit from further improvement. One of the main goals is to increase the predictive accuracy of the proposed AI-based threat intelligence platform. Although the current system is displaying promising results, further work is required to ensure that it can handle a broader range of fraudulent scenarios, especially when the inevitable new types of fraud emerge. Furthermore, exploring the potential of deep learning techniques for more complex cases such as account takeovers, deepfake scams, and generative AI fraud could potentially broaden the scope of our study and even further improve detection rates. Lastly, working alongside financial institutions to share information on new attack methods and metrics while masking and anonymizing the data, of course, like we did in this study, will be critical to provide our machine learning model with a more diverse data set. It will also assist in ensuring that our model meets regulatory requirements and can be implemented on a larger, perhaps even global scale. Thank you so much for listening.